Hey all, in this video we're going to solve quadratic equations by factoring. The good news is if you've gotten this far in the chapter and you've learned all the factoring methods, this section is actually really easy because most of the heavy lifting was done in those previous factoring sections. With this, what we're going to do is we're going to have an equation, so it's going to have an equal sign now. We're going to get it set equal to 0, so kind of write it in standard form, and then we factor completely, which is the hardest part of it, is the factoring. And then we just take each of those two factors, or three factors, however we end up with, set those equal to 0 and solve. And the reason for that is because if we have something of the form a times b equals 0, that can only happen if either a is 0 or b is 0, or they both happen to be 0, I guess. And we're going to use that with factoring because we get the set of parentheses times set of parentheses equals 0. If we can figure out what would make each of those parentheses come out to 0, that's going to be our solutions. So let me show you what that would look like. For this first one, it is not set to 0, so I'm going to subtract. I much prefer having a positive squared term. It's much easier to factor with a positive on the squared than a negative. So I'm going to bring everything over to the right-hand side and rewrite this as m squared. Subtracting this over would make it minus 10m. And subtracting the 24 over to the other side would make minus 24, and that would equal 0. So it is three terms, and it leads with a 1, so it's the friendlier kind of factoring where we can just set up the parentheses. And we'll throw some m's up front, and then we ask what multiplies to be negative 24 and adds to be negative 10. Careful, it's not the 6 and the 4, but it would be a minus 12 and a positive 2. Because we need opposite signs so that it comes back to that negative 24. And so then this last step, we set the factors to 0 and solve. So either this term is 0 and then 0 times whatever that is would make 0, or vice versa. So to figure that out, and I'll just show the steps on this once because after that it's pretty easy to see, we set m minus 12 equal to 0 and bring the 12 over, and m equals 12. And so that is called one of the 0 of this quadratic. So if I put 12 in there, I would have 12 minus 12 would be 0 times 14, and it would still make 0. Likewise on this side, m plus 2 equals 0. Subtract the 2 over, and we get m equals negative 2, which makes sense. If I put negative 2 in there, this term would be, or the factor would be 0, and this would be times negative 14, but it'd still be 0. Likewise, if we substitute those back into the original, those are the two values that would make that come up to 0. And so you can kind of see from the factors, if you have a factor of m minus 12, your 0 will just have the opposite sign from when you bring it over, so it'd be a plus 12. Likewise, if you have a factor with a plus, it will be a minus. So factors and zeros have opposite signs. This next example, so if we think back to all the factoring sections, step 0 on all of those is if there's a greatest common factor, get that out of your way, and in this case there is a 3 that's common to all of those. So I'll have x squared plus x, and that comes out to minus 56 equals 0. And then we ask what multiplies to be negative 56 and adds to be a positive 1. So that would be x plus 8 and x minus 7. This 3 has nothing to do with the rest of the problem. If it was a 3x, if there's an x in there to solve for, we would care. But when it's just a constant out front, it's not contributing to solutions. The two x's are the things that are going to contribute to solutions. It's an x squared, so we can have up to 2 answers, and then right here. So it'd be x equals negative 8 and x equals 7. And we'll see one in a second where, actually I think we'll see one right next, where that greatest common factor has a variable instead. So that'd be number 3. Again, it's not set to 0, so that's our first step on all these, is do whatever math we have to get it set to 0, so I'll add the 4m over. And then careful, that is not a difference of squares because it's a plus, and this is also, that m makes that not a square. So that is the too easy, it's really hard, it's just a greatest common factor. So we'll bring the m out front, and it leaves behind m plus 4. And if I set these individual factors, it's a squared, so I can have up to 2 answers. This one would just be m equals 0, because if n was 0, 0 times this would make 4 would equal 0. Likewise, if I put 0 in the original, 0 squared does equal negative 4 times 0. So that's what we'll see when we have a solution that's 0. It'll come out as a common factor. That's why back here where there was no variable, it's just a 3. That doesn't contribute to solution. And this would be m equals negative 4. This next one, so we factor, looks like it has a common factor of x, so we'll pull that out front. And then there's our difference of two squares, so we'll x, and then x plus 7, and x minus 7. And notice this one was cubed and has 1, 2, 3 x's, so it's going to have 3 solutions. So x equals 0 from out front there, negative 7 for that factor, and 7 for that last one. Okay, this one has squares on the ends, and so when we see squares on the ends, we like to assume it's going to be one of those perfect trinomial squares, so we'll try that and check ourselves. So 25x squared would be 5x, 36 would break down, that's a minus, so it's a minus. 36 would be 6 times 6. Remember, a double check is to multiply these two together and double it, and if it comes out to the middle, we're good. So 5 times 6 would be negative 30, times 2, there's the negative 60 that should be. With this one, once you can see what the solution is without doing the step, feel free, but let me just show you how this would look if I took that and set it equal to 0. I add the 6 over, and I divide both sides by 5. And so 6/5, in this case, it only has one answer. In quadratics, so they're squared, so they can have either no real solutions, one real solution like we saw in this case, or two real solutions, which is what it will mostly do. Once you can see that the solution to this is 6 over 5, no reason to show those steps, but just to show how I got there. So this one is a bit more involved. For this one, let's get everything over to one side. So I have squareds on both sides. I'm going to subtract p squared because I see if I go this direction, it's going to come out positive, and I might as well bring that 12 over while I'm here. So not my best handwriting there, but hopefully you can see p squared minus p squared, so that's gone, plus 12 minus 12, that's gone. And then over on this side we would have 3, oops, no we wouldn't. We would have 3p minus p would leave us 2p squared. 5p, nothing to go with that. And then minus 12 equals 0. And it does not lead with a 1, it does not have squares on the ends, so that means this is the kind where we have to do AC method. So 2 times negative 12 would be negative 24, and we need two numbers that multiply to negative 24 and add to be 5. So it sounds like 8 and negative 3. So we'll rewrite that with 4 terms. And then we'll take our common factors out, so 2p on those first couple, p plus 4. It looks like a negative 3 on those next two, p plus 4. And careful with that second sign, remember that these have to match. If we distribute back, there's negative 3p, and then negative times positive gets us a negative. So just remember that these two have to come out the same, and that can kind of help you when you're factoring that negative out. So factoring p plus 4 out front is going to leave me 2p and minus 3. So p equals negative 4, and then this one, bring the 3 over and divide by 2, and it will be 3 halves. And again, if you have a hard time seeing that, just do the steps and you'll get to that exact same spot. And then these last couple of examples are just, they're not quite, they need to be distributed out. So like this one, you might be a little tempted to do b equals negative 8, b equals negative 2, but we can't because it doesn't equal 0 on this side. So as long as there's something non-zero over here, we're stuck distributing this back and then incorporating that negative 8 over. So x times x would give us x squared. X times 9 is going to be 9x equals negative 8. And then we'll add the negative 8 over, and then we're in standard form. So this is the friendly kind. Trinomial leads with a 1, so we set up our parentheses. And we're going to lead with x's, and we just need two numbers that multiply to be 8 and add to be 9, so it sounds like plus 1 and plus 8. And so our zeros are going to be negative 1 and negative 8. And then lastly over here, this one's very similar, it's just a FOIL. So we'll go b times b for b squared. On the outside we get 2b. On the inside we get 8b. And on the end we get 16 equals negative 8. 2 and 8 would give us 10 there. And then we'll add the 8 over so that we get it equal to 0, and then we'll be in standard form. And then we're back at the parentheses, because 3 terms leads with a 1. And two numbers that multiply would be positive 24 and add to be positive 10, so that'd be a positive 4 and a positive 6. So our solutions are going to be negative 4 and negative 6.